Newton's third law, part 1. Let's go back to our definition of force for just a moment. A force is just a push or a pull. That means it has to act on an object, and it has to be exerted by a different object. So, an object cannot exert a force on itself. So, what is Newton's third law? Well, there are lots of ways to phrase it, depending on which website you read, which textbook you read, but let's go with the definition according to the College Board, who, let's face it, is the one writing the AP test. So here it is. If one object exerts a force on a second object, the second object always exerts a force of equal magnitude on the first object in the opposite direction. There's that equal and opposite again. So, how do we write it mathematically? All right, here, remember capital F is how we write force. Remember, it's a vector. Okay, so the left side is the force that A exerts on B. All right, the arrow is pointing at B, so A is acting on B. So that's going to be equal in magnitude in the opposite direction, hence the negative. All right, and it's B acting on A. Okay, so if I want to say this as one phrase, the force that A exerts on B is equal and opposite to the force that B exerts on A. Remember, the negative sign on a vector is really indicating the direction. It has nothing to do with the magnitude. Okay, so what circumstances must be true to use Newton's third law? There must be two objects interacting, and we must be considering the interaction between those two objects, not the interaction that either of those objects is having with any other object.